Okay. So see, we are going to discuss the questions. Mm, yeah. These things we will discuss at night. Now we are here to discuss the questions. Okay. So yeah. Okay. See, write down the first question, or if you have in a WhatsApp, I'd send. Let me tell you. Just open that PDF. Yeah, this one. Okay, means that gate PDF. Open it. Okay, I texted you on WhatsApp. Just open that PDF. Okay, Anish, have you opened it? Okay.
Yes, sir. Yes, sir.
So see, in the first question, what is the first question? It's a basic question. Question number one. Let me tell you. See, in question number one. Wait, someone is coming. Yeah. So in question number one, what it's written? Very normal question. Very normal question. Means you can see it. It's a 5 ampere current is going right. 5 ampere current. So what you are understanding from the question number one, Anish? Basic understanding. What is the basic understanding? What we have to find? See, this kind of a circuit. It's 10 ohm. This is 20 ohm. This is plus minus v of x is given, and yeah, so plus minus v of x is given, and it's 5 ampere current, and this is 8 ohm, and here it is given as positive negative 0.25 v of x, and from here to here it is given as 0.5 v of x. It's a current flowing in this circuit. Okay, so in this question you need to find the value of a vx. So how you will find the value of a vx? See, yeah, we have the current direction. This is 5 ampere. So 5 ampere current is going like this, and this is nothing but this is 0.5 v of x. So what will the current flow in this? Anyone? Apply the KCL. Incoming current is 5 ampere, and outgoing currents are, suppose this is x. So x plus 0.5 v of x. So what you are getting the value of x? 5 minus 0.5 v of x. So here we know the current in this. Okay, now the same thing, this we are taking this as a reference node, that is 0, because in this whole analysis, how many nodes are there? How many nodes are there? Can anyone say me how many nodes are there? Total number of nodes? See, these junction and these junction are the same junction, so it's considered as the one nodes only, and this is second node, this is third node. So total number of nodes is, total number of nodes,
Three.
yeah, 3. That's correct. Total number of nodes is 3. Okay, if you have the total number of nodes is 3, now apply the it is v of x only. This is v of x. This node name is given as a v of x, and this is this is 0.25 v of x. That's v of x only. Okay, so what I am telling, apply the nodal analysis here, apply the nodal analysis here. So x, I am taking the current like this, like this. So if you will apply the nodal analysis in this junction, what you will get? X current, suppose this is I1 current and this is I2 current. So x will be equals to I1 plus I2. Incoming current, outgoing current. What is the value of I1? Vx minus 0 by 20. And what is the value of I2? Vx minus 0.25 v of x divided by 10. And what is the value of x? 5 minus 0.5 v of x. Solve this and get the result, get the answer. So what you will get? Vx by 20 plus Vx by 10 minus 0.25 v of x. Solve it. Solve it. Try to solve this. So very easy. 20 into 5 minus 0.5 v of x. So v of x plus 2 v of x minus 0.5 v of x. So what the things will get? 3 vx, 3 minus 0.5. How much will get? 2.5. So 2.5 v of x. And if you solve here, 20 into 5, 100 minus this 20 into 5, 10 v of x. So 100 is equals to 12.5 v of x. So what the answer you are getting? The v of x value. 100 divided by 12.5. What is the answer? 100 divided by 12.5. 100 divided by 12.5. What will come?
8, sir.
Yes, 8. So 8 is the correct answer. 100 divided by 12.5. So the first question answer is 8. Question number 1 done. Anyone having any doubt? Question number 1 answer is 8. Anyone having any doubt? Or I can move to the next question. Anyone? Anish, is it clear?
Yes, sir, clear, sir. But sir, क्वेश्चन सब में सर पता नहीं चल पाता है जे सर मतलब अप्रोच कैसे लगाना है सर.
अप्रोच कैसे लगाना है? See, what you have to do ना. See, अप्रोच की बात ही नहीं है. अप्रोच कैसे लगाना है means what I'm saying to you, for solving the question, you should be crystal clear about the nodal analysis. See, here it's v of x is there na. So v of x we are taking the node value is v of x is given. This is parallel connected. 0.25 vx is parallelly connected to 8. So that means 0.25 vx value is this particular. Suppose you are taking a node v2 and this is 0 only, and v2 minus 0 is given you as a 0.25 v of x. So that's mean that directly you are knowing the value of a 0.25 vx. Always do, for solving this kind of a question, what you have to do, make a nodal points. You will get to know all the, because we are going to solve the 50 questions, so you will get to know these things very easily. Always make a node value, do the nodal analysis, apply the KCL, okay, put the value of I1, I2, and ultimately you are going to get the answer result. Okay, is this clear to everyone? Anish, is it clear?
Yes, sir. Yes, sir.
Okay,
yes,
okay.
Sir, yes, sir.
Now the second question. Write down the second question and see the second question from the workbook. So, in the second question, what it's written? What we have? See, question number 2. I am not going to dictate. It is with you. Everyone, the question is with you only, na? Everyone.
Yes, sir. Yes.
Prasanna is. Are you watching the questions?
Yeah.
Okay, then fine.
Yeah.
Yes, sir. पूरा सेंस दिया हुआ है जिसमें 1 का वैल्यू दिया हुआ है, अनदर का वैल्यू अननोन है सर, और दोनों पैरेलल कनेक्शन है सर.
Yes. See, this is very simple question. Question number 2. So two resistance are given. One is 30 ohm and another is unknown value. Okay, so it is given like 30 ohm. Okay, and another is unknown value are connected in parallel. So I am connecting, just simply connecting, these two are in parallel, taking R value. The total power dissipated in the circuit is 450 watt. So it's have some potential voltage, okay, and it will develop some current. So here it is given V into, it is positive, it is negative. So dissipated power means deliver power when current will. So this V into I, this V into I, it is given, the product of V into I, it is given 450 watt overall power, right? Now when the applied voltage and the value of a V is also given, that is 90 volt, right? You have to find the value of R. So 90 volt is here, that means it is also 90 volt. This is also 90 volt, right? So if you know the, wait, someone is coming. So if you know the value of a 90 volt is there, 90 volt in this question, this is 90 volt. So can anyone tell me what will be the current? You know the 90 volt, you know the 30 ohm. So what will the current? V is equals to I into R. So overall
5.
5. 90 into 3 na yaar, 90 into 30, how 5? 90 into 30 into I. So I is equals to 3 ampere na. 3 ampere current will flow, right?
Yes, sir.
Right. And and you know the value of a V into I. V is 90 and I into 450. So this value you will get 5.
5.
5 ampere.
Yes.
So these you will get 5 ampere, and you are getting here as a 3 ampere. So 5 minus 3, that means here the current is how much current is flowing? 2 ampere current is flowing. 3 is going in this branch and 2 ampere is going in this branch. And you know the value of this 90. So apply the V into I. V is equals to I into R, right? V is equals to I into R and get the value of R. How many resistance will get? Anyone? Prasanna? How many resistance will get? It's a very easy R. Don't take that much time. V is equals to I into R. So voltage is 90 only because it is parallelly connected. And I, you know the 2. And you know R. So R value will come as a 45 ohm. R is equals to 45 ohm. See, what I did now, it's given, it is in a question, it is given the product of V into I is 450 because this branch, this overall power dissipating is a 450. And if this is 90 volts, so that means the R resistance is also 90 volt because these two are parallelly connected. This is also 90 volts. So if 90 volt, if this is a 90 volt and we know the total resistance in this particular in this branch, so what will the current? 90 divided by 30, so 3 ampere current will flow, and by the use of the power equation we know the overall current will be 5 ampere, and then 5 minus 3 will get 2 ampere current. Now we know the 2 ampere current and the potential across this is a 90, so 90 divided by 2 you are getting the resistance value, that is 45 ohm. Anyone having any doubt in this, or we can proceed for the next question? Prasanna, is it clear?
Yeah.
Okay, so Anis, clear or any doubt?
Yes, sir, clear.
Okay, so yeah, now this is a very good question, very important and very good question. Here, what you first of all, what you are understanding from this question? Third question number 3. What you guys are understanding from the third question number 3? See, you have to make, it is given the number of capacitor, the number of 2 microfarad capacitor, 400 volt capacitor needed to obtain a capacitance value of a 1.5 microfarad rated. Means you have to make with the combinations of a capacitor whose rated value is 1600 volt, who can and means and one capacitor value it is given as a 2 microfarad. Okay, and one capacitor value will have a maximum voltage that is 400 volt. So how you will connect these capacitors so that you can obtain 1.5 microfarad capacitor? How can you obtain? So see, if you connect capacitor in a parallel, so this is all capacitor is 400, so this is 400, this is 400, so this branch is 400. Okay, similarly if you are connecting a capacitor in a parallel, so this is also 400 plus minus 400, and similarly if you are connecting three capacitor in a parallel, so this is also plus minus 400. Similarly you are connecting three capacitor in a parallel, so overall voltage how much you are getting? 600 1600, this is 400 only. So how much you will get? 400 plus 400 plus 400 plus 400, 1600 you are getting overall voltage, right? This is the value of a one capacitor is a 2 2 2 2, this is 2, this is 2, this is 2, this one is 2 2 2 2 2 2. So in a parallel capacitors are getting added, so it will make equivalent capacitor of how much? 2 2 2 6 6 6 6, and this is plus minus 1600, and these all are in series. In a series, what is the net equivalent capacitor? 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So what you will get? 4 upon 6, right? So you are getting the value. How much value you are getting? 4 upon 6. So 4 upon 6 is 1 by C equivalent. 1 by C equivalent. So 1 by C equivalent is equals to 4 by C. So C equivalent is 1.5 microfarad. So the answer for this question is 12 capacitor needed. Got it or not? See, see.
Once again.
See, in this question, it is the number of means a rating of the capacitor is given. You have one particular capacitor whose value is 2 microfarad, and the rating it's given, that is plus minus, it can hold up to 400 voltage only. So if we connect the similar capacitor parallel with this, the voltage value will be the same only, plus minus 400. Okay, but you need to make, in the question, see, in the question it's written you need to make 1600 value. So how many this kind of a combinations can be taken? More 3. So that's why I took 1 2 3 4. So we are getting the 1600 capacitance, and while solving the C equivalent, these threes are connected, so 2 plus 2 plus 2, you are getting 6 6 6 6, and these are connected in a series, so 1 by 6 1 by 6 1 by 6, so you will get C equivalent is 1.5 microfarad. So total number of a capacitor required to make 1.5 microfarad rated of a 1600 is 12, with the help of 2 microfarad and 400 voltage. Got it? Prasanna, got it? Prasanna, understood or not? Anish, understood?
Yes, sir.
Yeah.
Priyanka, Vijay, Raj,
Yes, sir.
everyone understood? Okay. Okay. So we solve this question number 3. So question number 3 done. And now go for the question number 4. So if you'll go for the question number 4, what is written? I'd already discussed this question number 4 in classes, previous classes. So see, you have some particular like this, it's given plus minus v, and it's 2 ampere, it's 2 ohm, this is positive negative 5 volt. Can we comment the v value? Option A is 9 volt, option B is 5 volt, option C is 1 volt, and D is none of the above. Can we comment? See, we know the branch current, that is 2 ampere current is flowing in this. So we can apply the KVL, minus V plus 2 into 2, 4 plus 5, but we don't know the potential of this particular X. This is ammeter, this is nothing but ammeter, so it will also have some potential na, some voltage drop na. So this voltage drop we don't know, because of this we cannot calculate the value of a V. So answer will be D, none of the above. This was GATE 1997 question. Okay, now question number 8. In question
Sir,
number,
please repeat, sir, once again.
see, Anish, what I am telling, it's a 2 ampere current, na 2, it's it it is 2 ampere current is flowing in this. So it will also have some potential. Either you can take, either you can take from positive negative. So these potential, this Vx value is not given. Okay, how much potential it's this instrument is requiring to develop 2 ampere current in this particular branch. So that's why we don't have the V of x potentials particularly across this element. But we know the voltage drop across 2 ohm because 2 ampere current is flowing. So positive negative will get 2 volt, 4 volt here. Okay, 2 into 2, V is equals to IR, so 2 into 2 it will give you 4 volt. So we will able to know that the potential drop will be 4 volt here, and here it is given potential drop is 5 volt here. Here we need to find the value of a V, but here current is given, the current element is given, that is an ammeter, that is not a simply a branch. It is just it is an a detector. So this detector will have some potential drop. This potential drop we don't know, so that's why we cannot calculate the value of a voltage V. Okay, clear? This part is clear? Okay, or any doubt? See what I am telling now. You guys have seen a galvanometer in your college, or
Yeah.
ammeter. So
It
for,
detects the direction of current.
yeah, it is giving the direction of a current, right? So see, ammeter is just like a measurement, means some particular current it's showing, right? It's connected with wire, right? So these 2 ampere, it's a ammeter only. Okay, it will have some potential drop voltage also. Okay, please off your mic, it's okay. So this please switch off your mic, please mute yourself, guys. So this is developing some potential, some. So it is showing 2 ampere, but this voltage, this how much voltage is required to show this 2 ampere current, it is not given in this particular value. That's why we cannot calculate the overall KVL here. Okay, now in a question number 8. So guys, what will the answer of a question number 8? Question number 8, it's a very simple question, not a tough question. 1 ohm, this is inductor, 1 henry, it's positive negative V of t, this is 1 ohm, and this is EBT and this is E of AT. So it will also have some potential here, but it's given the current we know. So if you know the current, so what current is flowing in this particular e power at, and what current is flowing from here, e power b of t. So what will be the current from here, e power at
E power 80 plus
e
e power
power
bt.
bt. So you know the current. So anyone can tell me what was the equation v of t for inductor? If current is coming I, this is positive, this is negative, it's developing some voltage. So v of t is equals to L di by dt, right? Right now v of t is equals to L di by dt according to Faraday's law. So we know the value of I. So I is our what? I is equals to e power at plus e power bt, and L value is given 1 Henry. So 1 Henry into d e power at plus e power bt divided by dt, that is your v of t. So what you will get, a e power at plus b e power bt. So v of t value you are getting a e power at plus b e power at. So answer will be what? Answer B is correct. Correct? Or anyone having doubt in this? E power at is flowing particularly from this branch, e power bt flowing particularly from this branch. Overall current is getting added. We are getting the value of the across the inductor, what kind of a current is flowing, e power at plus e power bt. We know the relations between v of t and I, that is v of t is equals to L di by dt. Put the value, put I value is e power at plus e power bt. When you differentiate it, you will get a e power at plus b e power bt. So you are getting the value of a v of t. So question number 8 is solved. Okay, Anis, understood?
Yes, sir.
Okay. Prasanna, Priyanka, Vijay, is this clear? Okay.
Yes.
Okay. So write down the next question. So in the next question, in the circuit of the figure, the value of a voltage source E you need to find. Okay. So some circuit is given like this, positive, negative, 2 volt. This is positive. This is negative. This is V2 element. And you have negative, positive. That is 0 volt is given. It's positive, negative. 1 volt is given. Okay. And here it is given positive, negative. E value you need to find. Okay. And yeah, it is split into this part. It is given positive, negative, 4 volt, and this is V of 1, and it is positive, negative, and this is 10 volt. This particular branch is right. This is right. Just wait for 2 minutes. Right. Okay. So this particular branch current is positive, negative, 5 volt, and this is 10 volt. You need to find the value of E. How you will find the value of E? How you will find the value of E? For finding the value of E, you need to find the value of what? Means like, see, if you'll go like this. Okay. So what kind of things you are getting? 0 plus 1 plus E plus 5 plus 10 is equals to 0. So E is coming how much? E is coming 10, 5, 16, minus 16. That's it. Solve. This is 0 volt, this 10 volt is 0 volt means it is grounded, and this 10 is, it's, you can assume as a positive negative, it is grounded. 10 volt, so if this is grounded, this is grounded, means this is imaginary line. So apply the KVL. Plus 1 volt plus 0 volt plus 1 volt plus E volt plus 5 volt plus 10 volt, and get the value of E. E is equals to minus 16 volt. Clear? This part is clear? Anis, it's clear? Priyanka, it's clear?
Clear, sir.
Yeah, okay. So I didn't did any things, means if you will go in particularly in this loop, now you will get to know the value of a v2. Okay, if you are solving, means let's solve the value of a v2. Just get the value of a v2. Minus v2 plus 2 minus 1 plus 0 is equals to what you will get. v2 is equals to 1 volt you are getting. Okay, now apply the same thing similarly in this way. How much you will get? Minus 1 plus 2 plus E plus 5 plus 10 is equals to 0. 10 5 15, 15 plus 2 15 plus 2 17, 17 minus 1 16, so E value is coming minus 16. Same approach. Now you can do also, you can apply from this branch also, but you need to know the value of a v1. So first find the value of a v1. Okay, so for that, but you cannot find the value of a, you can find the value of a v1, you can find the value of a v1 applying while using this. So minus v1 minus 4 plus 5 plus 10 plus 10 plus 10, you will get the value of a v1 is how much? v1 is equals to 15 minus 4 11, so 11 volt is here. Here v2 value is 1 volt is here, it is 0 volt, this is 10 volt it's given. Now apply the same thing in the form of a KVL, you will get to know the value of a E, that is minus 16 is coming. Okay, this part is clear? Anis, it's clear?
Yes, sir.
Okay. Now in the question number 10, question number 10, so it's a very simple question, not a tough question. It's 10 ohm, this is 5 ohm, this particular branch is 4 ohm, this is 5 ampere current. Okay, this is 4 ampere current, and in the circuit shown in the given figure, power dissipated in the 5 ohm, you need to find the power, how much power it will dissipate, how much power it will absorb. Okay, so how much power it will absorb, anyone? For finding the power you need the current and voltage. So assume one node, v1 here, v2 here, this is x, this is 0. So apply the KVL, current is coming, take the current like this and like this. So what will the equation? 4 ampere will be equal to v1 by 5 plus v1 minus v2 by 10. One equation is like this. What will the another equation? Apply the KVL, apply the KVL and get the answer. 5 ampere, 5 ampere is what? 5 ampere is entering, right now 5 ampere is entering. So if you apply the KVL, v2 by 4 you will get, and v2 minus, and you can take the entering current itself, means what is the overall entering current? v1 minus v2 by 10 plus 5 ampere, these two current are entering and it is outgoing current, so it will be equal to v2 by 4. So solve this equation and get the result of a v1 and v2, get the result of a v1 and v2. So 40 is equals to 2v1 plus v1 minus v2. So 40 is equals to 3v1 minus v2. And if you solve this, what you will get? 4v1 minus 4v2 minus 10 V2 is equals to minus 5 into 40. So
Sir, I think it's V2 minus V1 by 10.
V2 minus, no, actually I have assumed the current in this direction. Okay, see, incoming current, I didn't assume the current in this direction. Okay, if you will think like that, then the equation will be like this. See,
Plus 5 plus V2 minus
yeah,
V1
if you are
by
if you are
plus
thinking,
V2.
if you are thinking the current will go like this, so V2 minus V1 by 10 you are taking, so this,
Minus 5
so minus 5
plus V2 by 4.
plus V2 by 4. Yeah, you will get the same thing only. Means what I assume the current in this direction. If you are assuming the current in this direction, then V1 minus V2 by 10 will
Yeah.
come. Okay. And if you are assuming the
Okay, got
current
it.
in this direction, then V2 minus V1 will come. You need to apply only the incoming current and outgoing current. The things you will get the same only. Okay. Oh, let me put the charge on my laptop. It's so tell me the equation, final equation, what we'll get? What will get the final equation? 4v2 minus 4v1, right? And it is 40 into 8, 800, right now, plus 10v2 is equals to 0. So if you solve this, what you are getting, 14v2 minus 4v1 is equals to 800. Everyone is getting the same, means 14v2 minus 4v1 is equals to 800, or I did some wrong thing, just say me. Oh no, 5 for the 20, 200 you will get, no? 200. So 5 for the 200, so 200. Everyone is getting this. 14v2 minus 4v1 is equals to 200. Everyone? Solve this and tell me the value of a v1 and v2. Solve this equation 1 and equation 2 and tell me the value of a v1 and v2. You need to find the value of a v1. Why are you taking that much time? 14 into 4? 56. So we are getting 560, 14 into 3, 14 into 3, 42. So that is 42 v1 minus 14 v2. You have 14.
I got V1 as 20.
v1 is equals to 20. Okay, and v2 value will be, put the
Yeah, calculate.
okay, put the value, and if you are getting the value of a v1 is equals to 40, so 40 into v1 is 60 minus v2, so v2 will come as a 20, right? v2 will also come 20 only. If you know the value of a v1 is 20, so 20 divided by 5, 20 divided by 5, you are getting the value of I current is 20 by 5, 4 ampere current you are getting. Okay, then put I square into R. So 4 4 is 16, 16 into 5. 16 into 5 is 80. So 80 watt. Option will be B. Right? This part is clear to everyone. Anis, is it clear? If you are facing any doubt now, you can ask. Don't hesitate for asking doubt at all. Okay. So guys, the question number 10, the answer will be 80 watt. Okay. So see the question number, next question. See the next question. Prasanna, please mute yourself. Yeah. So question number 11. How can we solve the question number 11? So the current in the given circuit with a dependent voltage source is. So you have to find the current value. Question is, you have 1 ohm. This is negative, this is positive, and this is 2 VB. It is given. Okay. And it is given plus minus 3, and this value is given VB. Means whatever the voltage will develop, it will be VB only. And this particular thing is 4 ohm. And this is positive, negative. This is connected. Positive, negative to 24. Positive, negative 24. Okay. So suppose I current is flowing in this. Some I current is flowing in this. So what you will make a KVL equation. If you are making a KVL equation, minus 24 plus I minus 2 VB plus 3 into I plus 4 into I is equals to 0. So what is the equation you are getting? 4 plus 3, 7. 7 plus 1, 8I. 8I minus 2 VB is equals to 24. Equation 1. And here it is given the potential, the voltage across 3 is VB. So 3 into I value, it is VB only. Okay, 3 into I means 3 into I, it is a voltage across this resistor, and it is given VB. So what is the relations between I and VB? I and VB. I is nothing but VB, or what is VB? VB is equals to 3I. You need to find the value of a current now. So 8I minus 2, put the value of a VB as a 3I, 24 to a 6, 8I minus 6I, 24, 2I, 24, I is equals to 12 ampere. Right? So answer will be B. This thing is clear. This part is clear. Anis, is it clear how I solve this?
Yes, sir.
Okay, Anis, great. Prasanna, it's clear. Priyanka, it's clear. Vijay, is it clear? Guna, is it clear? Okay. Next, now let's go for the another question. So we solved up to question number 11. Let's try the question number 12. So I already discussed this question in a class, but here also I will solve it. You have a infinite capacitance circuit. This is an infinite capacitor circuit. It's moving like this. It's an infinite. Okay. So you need to find the value of AB. CAB. You need to find the value. All the capacitor value is C. C. So for solving this question, what you need to take?
C equivalent.
C equivalent. So particularly you are assuming this as a CAB. So you are getting C, this is C, and this will be CAB, and this is also CAB by saying this. So these two are in series. So what will be the net value of this? C into CAB by CA plus CAB, right? This part is clear? C plus CAB. Okay. So you are getting I'm assuming this as a x value. You are getting some x value here, and this is your c value, and this is CAB. So these two are in parallel, so it will directly add it. C plus x is equals to CAB. Now solve this problem. Solve the equation. Assume CAB as a C dash. C plus C into C dash divided by C plus C dash. So C dash C square plus C dash plus C dot C dash. So what you will get? And here it is multiplied with C plus C dash. Okay. So what you will get, guys? C square plus C dash, C dash. So C square plus 2C C dash is equals to C dash square plus C dash square. So this will be cancelled. So C dash square minus C dash minus C square. You need to find the value of a C dash. So C dash, apply the discriminant. C dash is equals to minus B. So C plus minus root under B square, C square minus 4AC. So plus minus minus will become plus 4C square divided by 2. So C dash is equals to C plus minus C is coming outside, and it is root under 5 upon 2. So what you will get? C common 1 plus minus root 5 by 2. So you need not to you should not take the minus sign, because if you will take the minus sign, the value of a C will come in a negative. So what is the correct answer? C dash is equals to C by 2 1 plus root 5. So answer will be D. Is this clear to everyone? Anis, clear?
Yes, sir.
Guna, it's clear? Raj, it's clear? Priyanka? Vijay? Okay. So we solve the question number 12. Question number 12 done. Now a simple question. Again one simple question. So find the net equivalent. You need to find the net equivalent. See, you have 9 Henry here. This particular is 10 Henry. This is 6 Henry. This is 4 Henry. This is A, this is B. This thing is 12 Henry. This is 3 Henry. How you will solve this? Guys, how you will solve this? So this is clearly, we can see clearly these two are in series.
9, 3 and are in series.
Yeah, 9, 3 are in series. So it is 12. Okay.
12.
Yeah. And this particular two are in parallel. Right? So it is 12, and we are making as a 10 Henry. This is 6 Henry. This particular we can draw like this 12, and this is 4 Henry, and this is connected like this. So this 6 and 12, this is A, this is B. So 6 and 12 are parallel. So 6 into 12 divided by 18. So 6 into 3, you are getting 4. So you got 12, 10, 4. This is 4A, B. Right. Now this 10 and 4 are in series. So you are getting like this. Just do one thing. Yeah, just do one thing. These 10 and 4 are in series. So this is 14, and from this point to this point you have 12. Okay, and you have one point is here 4, and this point is this point is B. So can anyone tell me these two are in parallel? So 12 into 14 divided by 12 plus 14, how much? 26, right? So you are getting this is A. So you are getting 26, and this particular is 4. This is A and this is B. So it will be 12 into 24, 12 into 14 by 26. So solve this and get the result. So how much value you will get? I think I did some wrong. 10.466. So I am getting 10.466. So it will come across 11. Okay, let me try with a different way. Command C. Section command B. Yeah, for solving this kind of a question we know a very beautiful thing. See, you are assuming A, B, C, D and E here. Okay, so yeah, make A point here and make B particular point here. So from A to C, which branch is connected? From A to C, how many inductor are connected? 4 Henry. Okay, and from C, and you are taking D particularly this side, and from C to D, that's a 10 Henry, and from D to E, suppose we have some particular E here, D to E, this is E, D to E is 12 Henry, and in between E to B it is shorted. So your E and B is shorted, that means it is the same point only. So consider it as the same point. Okay, and from B to C, I am considering the same point. This is the same point only. Okay, this particular is B point only. So no need to make. So from D to B it's 12 ohm. Okay, and from C to B it's 9 plus 3, 12 ohm. 9 plus 3, 12 ohm. Okay, so this particular we are getting like this, and this is C to B. What I told, that is D, na? Yeah, so C to B. So you have to take from here, and this 12 and 10 are connected in series, so it will be 22. Okay, so you are getting 4 Henry, and this
10 Henry inductor is sorted, sir. You have missed the sorting between C and D.
Okay, I missed the sorting, na? Okay, great. So it is shorted. Oh, thank you for telling me. So this is shorted, so that's why I'm not getting. So it is shorted, so it is not no use. Okay, it will become redundant. Part. 4 Henry, it will become redundant part. This is 12 and this is 12, and you have to, this is your B, this is your A. So if this is shorted, so this 12 and 12 will be in parallel, so you will get 6, and this is 4, so you are getting 6 plus 4, 10 Henry. Yeah, correct. So this part is shorted. If this part is shorted, so these C and D will become same. If C and D will become same, so this 12 Henry and 12 Henry will be in a parallel. If 12 Henry and 12 Henry parallel, so you will get the 6 Henry, and this 6 Henry plus 4 Henry, you will get the result as a 10 Henry. Am I correct? Is this clear to everyone? But the answer you are but we are not having the answer as
7 Henry is the answer, sir.
7 Henry. How
Yeah.
so?
Sir, 9 plus 3, 12 Henry. 12 Henry is then parallel with again 12 Henry, then it will become 6 Henry, and then 6 Henry plus 6 Henry parallel with Henry.
1 minute. So explain from beginning. Means 9 Henry is there. Okay.
9 Henry plus 3 Henry in series, then it will become 12 Henry.
Okay.
And 12 Henry parallel with 12 Henry, it will become 6 Henry.
Yes.
And then 6 Henry is parallel with 6 Henry, it will become 3 Henry. And 4
Okay,
plus 3
okay,
is
okay,
27.
okay. You are saying like this. No, that is 6 Henry. We missed that point also. Okay. So correct only. So means 7 Henry will get the answer. Right, right. So this is 9 Henry and 3 Henry. It's a 12 Henry. 12 Henry is there. This is 12 Henry. So this will give you the 6 Henry, right? And these 6 and 6 are connected, parallelly connected. So it's a 3 Henry. And this is shorted. So it will be shorted, and 6 plus 3 will give you a 7 Henry result, right? So let me tell you once again. Yeah. You are correct only. Yeah, it's correct. So thanks for explaining this part. See, we have 9 Henry, and this is 3 Henry. Okay, this particular is 10 Henry, and this is shorted. This is 4 Henry, and this is 6 Henry, and this particular is 12 Henry, and it is connected like this. So this is A, this is B. So we are getting this as a series connection. So it's a 12 Henry. Okay, and this 12 Henry we are getting this as a 12 Henry, and this particular both it is a shorted. So that means it's a short point. Okay, and this short point, it's connected. We are again having 12 Henry. This particular are connected like this, and from this we have 6 Henry, and this is connected like this, and this is particularly B point, and this particular is 4 Henry, and it is A point. So if you will, these all three are in a parallel. So 12 you will get 6 Henry, and this 6 Henry are in parallel. You will get 3 Henry. So 3 Henry plus 4 Henry, you will get 7 Henry. Correct? Is this clear to everyone?
So we don't have to take that 10 Henry value, right?
Yeah, you don't have to take the 10 Henry because it is short circuit. If any, see, suppose the thing is that now, if any resistor or any capacitor or any inductor, it is directly, it's if it is like this, means if the shorting is like this, then it will become redundant part. So this will become redundant part. Okay, if a shorting is happening, so current will directly go here. It won't go in this side because it have the shortest path. So this is the basic concept I taught you in the previous classes. If you have a short circuit across the resistor or inductor or a capacitor, so current will flow in this part. It will become a redundant part. You have to remove that part. So that's why we remove that part, 10 Henry part. Okay, is this clear, Prasanna?
Yeah.
Anis, it's clear?
Yes, sir.
Okay. So we discussed up to question number 13. So we'll discuss question 14 to 15. Tomorrow means if I'll have a time in afternoon, so I will discuss the question from 14 to 20 or 24. Okay, at night we'll start the interconnections part of the two-port network. So be there. Okay, thank you very much, guys.